Assalamualaikum and good morning, class. Okay, we are still in the chromosomal mutation. Okay, now we go to the last part, which is the changes in the number of chromosome per cell. Okay, now changes in the number of chromosome per cell. Okay, means it is the changes in the number of chromosomes in a genome of an organism. So meaning to say the number of chromosomes that you have changed. Okay, so there are two types, aneuploidy and euploidy. Okay, so today's lesson we only cover aneuploidy. Right, aneuploidy is the condition of an organism that gains or loses one or more chromosomes in its genome. Euploidy is a condition where an organism having 3 or more complete haploid sets of chromosomes. Okay. Okay, before you proceed, you watch this video about nondisjunction, which is the main cause for aneuploidy. Okay, go back. All right.
Do you know anyone with Down syndrome or Klinefelter syndrome? These are examples of chromosomal disorders, which are due to nondisjunction. When nondisjunction occurs during meiosis 1, replicated homologous chromosomes do not separate correctly. One daughter cell retains both replicated chromosomes. The other daughter cell lacks that chromosome. When a haploid sperm fertilizes an egg with an extra chromosome, trisomy occurs. When a sperm cell fertilizes an egg that lacks a chromosome, monosomy results. In this scenario, either a trisomy or a monosomy results. Nondisjunction can also occur during meiosis 2. In this scenario, meiosis 1 occurs normally. When the daughter cells separate during meiosis 2, one daughter cell divides normally, but the other daughter cell divides abnormally. One egg lacks a chromosome while the other egg has an extra chromosome. When a haploid sperm cell fertilizes a haploid egg, a normal diploid results. If the sperm cell fertilizes the egg that lacks a chromosome, then monosomy results. If the sperm cell fertilizes the egg with an extra chromosome, then trisomy results. In this scenario, there is a 50% chance of a normal diploid, a 25% chance of a monosomy, and a 25% chance of a trisomy.
Okay, class. So from this video, okay, you know that non-disjunction, okay, during meiosis 1, okay, as well as non-disjunction that occurs during meiosis 2 will produce different results. Okay, if you recall that if the non-disjunction occurs during meiosis 1, you'll get either trisomy or monosomy. Okay, if the non-disjunction occurs in meiosis 2, you get diploid and trisomy, is it? Okay, so the outcomes are different. Okay, now let's proceed. Aneuploidy, okay, is a condition where organism gains or loses one or more chromosomes in its genome. Aneuploidy can occur in autosomes and sex chromosomes. Okay, so today you're going to learn aneuploidy in autosomes as well as aneuploidy in sex chromosomes. Okay, now aneuploidy in autosomes are represented by 2n plus or minus the extra chromosome. Okay, now wait, let me get my pointer here. All right. When a normal gamete unites with gamete containing 2 copies or no copies of a particular chromosome, okay, this is the gamete that do not contain any copy of a particular chromosome, as you can see from here, okay, because of the non-disjunction in meiosis 1. All right. Now this diagram here only a given example, what happen if non-meiosis, if the non-disjunction occurs in meiosis 1, right? And this diagram here, it tells you what happens when the non-disjunction occurs in meiosis 2. You can see here the non-disjunction correlates with the meiosis 2. And this one, the non-disjunction correlates with the meiosis 1. Class, you must really understood this diagram here. Alright, why this is n plus 1, n minus 1, and then this is the haploid, which is normal. Okay, this is the trisomy, and this is the monosomy. Okay, let's go back to the paragraph number 2. When a normal gamete unites with gamete containing 2 copies or no copies of a particular chromosome, the resulting zygote and its descendant cells either have one extra chromosome, which it becomes trisomy. You know that when a when a haploid gamete, okay, from the male fuse with the haploid gamete from the female, you get 2n, which is a diploid organism. Okay, now in here in aneuploidy, what happened? Okay, if the female gamete, okay, it has one extra chromosome. Okay, so that organism, okay, that develops from the fusion of those gametes will be 2n plus 1, right? And if one of the gamete lacks one chromosome, so the offspring will be a monosomy, 2n minus 1. Okay, 2n means it's a diploid organism. Minus 1 means that organism lacks one chromosomes. Okay, one chromosome. And 2n plus 1 means that organism is a diploid organism that has one extra chromosome. Okay, and an organism that lost both pair of chromosome would be nullisomy, 2n minus 2. Okay, and a diploid organism would be 2n, disomy. So all of us are disomy. Now this aneuploidy, okay, in autosomes caused by non-disjunction during formation of gamete, which is this autosomes aneuploidy occurs, okay, during spermatogenesis or oogenesis. Okay, all right. So this is a karyotype which displays all the chromosomes of an individual. Okay, so 1 represent chromosome number 1, okay, or homologous chromosome number 1. Same goes for number 2, means homologous chromosome number 2, and so on until 22nd. So because we have 22 autosomes, right? One gamete has a 22 chromosome, and then we have a sex chromosome. Okay, so this is XY. So now you tell me, this karyotype, does it belongs to a normal male or female? Yes, it belongs to a normal male because of the sex chromosomes here, which is XY. Okay. This is a karyotype of a Down syndrome individual. Okay, now, what is the peculiar about this karyotype? Okay, if you examine this karyotype closely, you'll notice that on the 21st autosome, there is an extra here. Okay, it's an extra chromosome here. All right, so this will be a 2n plus 1, right? Because it has an extra chromosome on the 21st chromosome, or chromosome 21. Okay, yes, extra chromosome or extra copy of a chromosome on the chromosome 21. Now, the presence of an extra chromosome, okay, on chromosome 13, 15, or 18 causes severe developmental defects, and infants with such a genetic makeup will die within few months. Okay, now example, the syndromes here are the Patau syndrome and Edwards syndrome. Patau syndrome is also known as trisomy 13 and Edwards syndrome trisomy 18. Now, what does this trisomy 18 and 13 tells you? Meaning to say, on the like for example, the Patau syndrome, okay, individual that is suffering the Patau syndrome will have extra autosome on the chromosome 13. And individual in Edwards syndrome, okay, right, individual in Edwards syndrome will have an extra of autosome on the chromosome 18, right? Now, in contrast, individuals who have an extra copy of chromosome 21, okay, meaning to say, individual who has an extra autosome on chromosome 21, right, or more rarely, okay, chromosome 22 usually will survive to adulthood. So meaning to say, individual has extra copy of chromosome on chromosome 21 or rarely on chromosome 22 will survive to adulthood. This is different within this is different if you compare with the chromosome 13, 15, and 18. Now, in this individual or this group of people, the maturation of the skeletal system is being delayed. So they are generally short, have poor muscle tone, and then their mental development is also affected, meaning to say they retards. Okay, and children with trisomy 21, okay, are always mentally retarded to some degree. Example is the Down syndrome. That's why Down syndrome also known as trisomy 21, which is chromosome number 21 has an extra copy of autosome. Okay, now this chart here to tell you that this non-disjunction can occur in meiosis 1, okay, like what's being shown here, as well as in meiosis 2. Okay, now apart from occur in meiosis, okay, non-disjunction also can happen in mitosis. Okay, now in your syllabus, this section is already removed. They emphasize on you studying non-disjunction that happen or occurs in the meiosis, right? Okay, so this is Patau syndrome. Okay, now you need to know what are the things that you need to know. Okay, you need to know the Patau syndrome is also known as trisomy 13, and then extra copy of chromosome on the chromosome 13. You need to know that. And then Patau, spell the name, okay, capital P. And then the characteristics of individual of this Patau syndrome. You must know these characteristics. Okay, so these are their characteristics. You read this on your own, all right? Okay, so Christian, all right? Okay, so this is Patau syndrome. Okay, extra copy of chromosome on chromosome 13. All right. Now, class, having an extra finger doesn't pinpoint or tells you that that individual is a Patau syndrome. Okay, it's not necessary. Just in case if you have an extra finger, but you don't have this cleft lip, for example, you are not a Patau syndrome individual. Okay, otherwise, lagipun, you see, it's quite impossible. Okay, they normally they individual in Patau syndrome, they'll die within the first 3 months after birth. Okay, impossible for you to grow up to be in the form 6. All right. my point is, when you see someone, an adult with this cleft lip, he or she is not a Patau syndrome, right? Those are Patau syndrome, they can't live beyond 3 months old. Okay, this is Edwards syndrome, right? Trisomy 18, Edwards with S here, right? And then these are the characteristics of Edwards syndromes as well as here. Okay, so you read this on your own. Okay, this is trisomy 21. Look at the chromosome 21, an extra chromosome here. All right, and this trisomy 21 also known as the Down syndrome, and this is their characteristics. Okay, and Down syndromes, Patau syndrome, as well as the Edwards syndrome, they can be male or female, because this is only involve the aneuploidy in their autosomes. Okay, doesn't involve their sex chromosomes. Right. Now, aneuploidy in sex chromosomes are caused by non-disjunction during gamete formation. It is very similar to those aneuploidy in the autosomes. Okay. Now, the difference here is that aneuploidy in autosomes, it involves the non-disjunction of the autosomes, chromosomes of the autosomes. But non-disjunction of the sex chromosome will result in aneuploidy in sex chromosomes. Now, we go to this first example. Yeah, 3 examples here. Non-disjunction of the XY pair during the first meiosis. So we know, okay, this is example of the Y chromosome and this is the X chromosome. Okay, during anaphase, they did not separate properly. Okay, by right, the X chromosome, sorry, the Y chromosome should have gone to this polar. Okay. All right. Non-disjunction of the XY pair during the first meiotic division in the male may lead to the formation of a sperm with both X and Y chromosomes, or a sperm with neither an X or a Y chromosome. Okay, so sperms or gametes, okay, with the XY chromosome happen to be XY, okay, and it will give another sperm that lacks of the sex chromosome. So what happened when this gamete here fertilize a normal gamete from the female, a gamete that carries only X chromosome? What will happen? The individual will have XXY. The same goes for this one. If this sperm fertilize an X gamete, it will give out an XXY. What about this one? If this egg, this sperm fertilize, okay, a normal gamete which has the X chromosome, so it will form an individual with XO, right? O represent means lacks of either X or Y chromosome from the male gamete in this given example. Okay, now this is non-disjunction of the XY pair. Okay, one case example done. Next, Y chromosome non-disjunction. Okay, so what happened here? The Y chromosome failed to separate in meiosis 2, as you can see from here. Earlier, XY failed to separate in meiosis 1. So now, the Y chromosome disjunction. This will lead to the formation of YY gamete. Can you see here, the YY gamete? Okay, because of the non-disjunction of the Y chromosome in meiosis 2. Now, when this gamete, this YY gamete combined with X gamete, okay, the XYY zygote will develop into a fertile male of normal appearance, and this is known as Jacob syndrome. Okay, so Y, okay, fertilize an X gamete becomes XYY, right? If this sperm fertilize an eggs, okay, what happened? You get a normal individual with X, Y. Same goes for this sperm. What about this sperm here? If it fertilize an X gamete, you get an XO, right? Okay, now this is the karyotype of an individual in Jacob syndrome. Okay, 47 XYY or 44 plus XYY. 44 here, it tells you that the number of the autosomes are normal. Remember, a haploid gametes from a diploid organism has 22 autosomes. 22 from the male fused with the 22 from the female, you get 44. Okay, by right you should get 44 plus XY. A normal individual will give 44 plus XY. But Jacob syndrome is 44 plus 44 plus XYY. Now, or you can write as 47 XYY. Why 47? Okay, 44 here plus 3 sex chromosomes here. How much do you get? You get 47. Okay, 47. And then the anomaly yang ganjil, which is the XYY. So this is an individual of the Jacob's syndrome. Oh no, sorry. Yes. XYY. Sorry, this is not Jacob syndrome. All right, this is XXY. Okay, this is Klinefelter. Okay, this slide shouldn't be here. Okay, so class, you Google up for the Jacob syndrome. Okay, their appearance, their characteristics. Miss out in this slide here. Okay, we go back to this part later. Now, X chromosome disjunction. When X chromosome non-disjunction is a condition when the X chromosome fail to separate in meiosis. Alright, in meiosis 2. Some of the gametes produced will possess both X chromosome, which is XX gametes. Okay, because the X chromosomes here should be separated, but it failed. So you have XX gamete, and the other gamete will have no sex chromosome, which is designated as O, or nothing. Okay, so what happened when this particular egg fertilized by Y gamete from the sperm? So you have Y XX or XXY. Okay, XXY, which is this one. And this egg, if you fertilize, let's say an X from the sperm, you get XO. Okay, there is no OY, right? If this fertilize an X, you get XO. If it fertilized with an Y, okay, there is no such thing as OY. Okay, it's a non-viable. The individual it won't happen. Okay, takkan hidup lama. Okay. Or I can say that the formation of the zygote will fail. Alright. Now, if an XX gamete combines with an X gamete, the resulting XXX zygote will develop into a female with one functional X chromosome. Okay, now you know that there are 3 X chromosomes here. Only one would be functional, and the other 2 would be non-functional or deactivated. And those deactivated X chromosomes are known as bar bodies. Okay, non-functional X chromosomes. This is known as a triple X syndrome. You see, triple capital T with capital X. So 44 plus XXX or 47 XXX. Now, individual in this triple X syndrome is a female. Okay, obviously there is no Y chromosome there, so she will have undeveloped sex organs. Okay, weaker muscle tone, or the term is hypotonia, and then she will be taller than average heights of girls. then problems with fine and gross motor skills, but is otherwise this individual in triple X will appear normal. Okay, I mean, when you meet someone that is triple X from the outside, she appears to be normal, just like you. Okay, but if you examine closely, she will exhibit these phenotypes. Right? Okay, this is triple X. Okay, this is how they look like. They appear to be normal. Okay, appear to be normal. Poor breast development. Yeah, now normal female, some of you have your breast is not as big, or I say uh, as big as, or I can say that with your peers. All right, maybe it's quite small, but that doesn't mean that you are a triple X syndrome. Right? These are some of the characteristics of the triple X syndrome individual, and each individual may or may not exhibit each of these characteristics. Okay. Now, if an XX gamete, okay, instead combines with a Y gamete, the effects are more serious. The resulting will be a XXY zygote. Okay, because of this Y chromosome, it develops into a male. Okay, with one bar body. Okay, why one bar body? Because now there are two X chromosomes here. Only one will be activated. The other X chromosome will be deactivated. So, deactivated or inactivated X chromosome. There is one. So, one bar body. Okay, now this individual, XXY individual, okay, has female body characteristics. And in some cases, okay, not all, they experience diminished mental capacity, okay, or simply say retards. This is known as the Klinefelter syndrome, 44 plus XXY or 47 XXY. Now, the physical characteristics, they are male with developed breast. Now take note, the breast is not as big as the female, okay, but their breast is very noticeable. You can see that they have breasts. Smaller testes, okay. Longer limbs means their legs or hand, arms are longer. Okay, it's quite unusual. Okay, you can recognize them. When you see them, you know that they are the Klinefelter because their limbs is quite long. And they have wider hips. Usually they are sterile, okay, and mentally retarded. Sterile means tidak subur. Alright. Okay, this is the Klinefelter syndrome. Right? Or this diagram here. Look at the limbs. Tengok tangan dia. So long. Right? And then look at the hip. Female hip. Female hip. Man, normally your hip here is broad, it's straight. You have a very straight body here. That gives the appearance of an alpha. Okay, this is female hip. This is the undeveloped, sorry, this is the developed breast. Okay. All right, and then their pubic hair. Okay, they have this female type pubic hair pattern. Okay, which is which is a pyramid type. A normal male, we have an inverted pyramid like this. Okay, a female would have a pyramid pubic hair shape, right? Okay, this is Turner syndrome. All right, Turner syndrome. Okay, now if an O gamete, meaning to say a gamete that lacks of neither the X or Y chromosome, fuses with an X gamete, right? What happened? The XO zygote develops into a sterile female because of the presence of the X chromosome. Okay, now the sterile female will exhibit short stature. Okay, maksudnya pendek lah, dia tinggi. Okay, and then web, how do you pronounce this? Web neck. Okay, and then sex organs that never fully mature during puberty, or we can simply say unmatured or immature sex organs. And then their mental abilities also in the low normal range. All right, they are not retards, but their mental abilities is not as good as the normal individual. And this is the Turner syndrome, which is 44 plus XO, or 45X. Why 45X? 44 plus 1 sex chromosome becomes 45. Okay, so 45X. Now, if an O gamete, okay, fuses with a Y gamete, the resulting is OY zygote, which is non-viable and fails to develop further. Humans can survive when they lack the genes on the X chromosome. So this is the Turner syndrome. All right. They have this navy on their skin, which is very apparent. Okay, sangat ketara. Okay, can you see the web neck? Okay, sian. Okay, so those of you, right, in class, you are normal. So be grateful. All right, so study, because if you compare yourself with these individuals, you are far more superior. Right, so be thankful and study to be someone who can give out something to our nation. All right, okay. Now, class, individuals who gain or lose a sex chromosome do not generally experience the severe developmental abnormalities caused by similar changes in autosomes. Okay. Although such individuals have abnormal features, they often reach maturity and in some cases may be fertile. Alright, so meaning to say, individual, okay, with sex chromosome aneuploidy, they do not experience severe effects compared with individual who is autosomes aneuploidy or aneuploidy in autosomes. Keadaan orang yang ada aneuploidy autosomes ni lebih teruk compare dengan orang yang aneuploidy in sex chromosomes. Okay. Okay, if you compare individual in aneuploidy sex chromosomes and aneuploidy autosomes, okay, yang autosomes within 3 months dah dia boleh hidup dah, right? Dia mati kan, which is the adult syndrome. Okay, Down syndrome is different. Okay, but when you compare with those aneuploidy in sex chromosomes, okay, some of them are fertile and they can they can reach adulthood. Example, the Klinefelter syndrome and the Turner syndrome. All right. Okay, so this chart here, okay, summarize the aneuploidy. All right, in humans. All right, this trisomy is the autosomes aneuploidy, and this here is the sex chromosomes aneuploidy. All right, so it's either triple X or triplo X. Okay. All right, 2013 STPM. Okay. Which genetic abnormality is caused by base deletion? Obviously, it is not Down syndrome and Klinefelter syndrome. Is it sickle cell? Sickle cell is the substitution of the base. Okay, it's not, the base is not being deleted. So the answer is thalassemia. Okay, what would be the end products of meiosis? Okay, now you try to answer this question first. Okay, pause the video now. Try to answer this question on your own. Okay, done? Alright, so the answer is A. Alright? Alright, okay, now, which row of person suffering Down syndrome? What's your answer? Okay. Remember, class, again, please pause the video. Alright? You only play the video after you have done answering the question. Okay, extra autosomes, right? Trisomy 21. Chromosome 21 has an extra chromosome. Okay, 2015. Chromosomal mutation. What do you think the answer is? Obviously, it's Turner syndrome, right? And Chat. Okay, test your knowledge. Okay. Okay, so I just pressing the answer, right? Press the video if you pause the video if you have not answered the questions yet. If you're done, okay, you may play the video. Continue to play the video. All right. So this is the answer. All right. Okay. Human has 3 bar bodies. 3 bar bodies. 3. Means so it must have 4 X chromosomes, because 1 X chromosome will be activated. The other 3 will be deactivated. So 3 deactivated X chromosomes means 3 bar bodies. Right? Okay. All right. If you understood the diagram which I explained earlier, okay, the animation, so you should be able to do this one. Okay. All right. Severe, more severe. Okay. 21 should be 22 or 24. Sorry, 21. Sorry, it should be 22. This is 21, like 1 autosome. All right. Okay. All right. Okay. All right. 60. Okay. There, 2017. Okay. 17. All right. So, what's your answer? Okay, so these are the answers apparently. Okay. Okay, NFS. Okay. Okay, now the C2, it says describe 3 physical characteristics. So characteristics that can be seen, physical. Okay. All right. So these are the answers. Some books, for Klinefelters, they said the individual has female voice. Female voice, having a female voice is not something that can be seen physically. Okay. So it cannot be as part of the answer here. All right. Okay, so this one is quite complicated. Take your time to do these questions. All right. Okay, after you have done, then you refer here. Okay, so you have to draw this diagram here. That's why earlier part of aneuploidy, okay, there is one section there where I purposely left blank in the nondisjunction diagram, because I want you to draw the gametes. Okay, so you are able to answer this kind of question should this kind of question reappear. Okay, and then the Punnett square, right? Okay, describe how. Right, so this is the answer. Okay, suggested answer. So that's it for today. Okay, it's 38 minutes, almost 39. Okay, so thank you. Any questions, please ask us. All right, thank you so much, Michael.